This is Nathan Skipper with Montgomery Technology Incorporated, and in this video I'd like to explain the logic devices related to the MTI Control System. This video is part 4 in the MTI Control System Technician Training video series that is available from our company. In this video we'll look at the logic structure, the power systems, grounding, and ground faults for these systems. The MTI logic structure is made up of some major components that are there for every MTI control system. Those major components are the embedded controller, which is the 91795, the data loop converter, which is the 91620, and the decoders or I/O cards, which consist mainly of the 81650 and the 81611. These devices handle the intercommunications and the logic related to all of the actions taken on the MTI control system. If you look at the diagram to the right, figure 0401, you'll see a typical logic diagram for how the system is laid out. You have there in the center bottom, you have the MTI embedded controller, which is the 91795. Tied to the network switch. You have the 91620, which connects to the network as well, but also connects via the MTI data loop to all of the termination boards. And then you have the decoders, which are plugged on to each of those boards. From a user input through the MTI control station Provision software, that input is sent to the embedded controller via TCP/IP over the Ethernet, and then from the embedded controller that data is converted into a 64-bit output, which is sent to the 81620, and then from that 620 it is converted into the MTI data loop, which is then passed down to the I/O card or the decoder. The decoder takes that and translates it into actual physical outputs to a field device. And then in reverse, the field device input goes to the I/O card or decoder. The decoder translates that onto the data loop to the 620. The 620 then translates that to TCP/IP to the embedded controller, and then the embedded controller applies the logic and passes that on to the user interface on the MTI control station. Power is an extremely important consideration when talking about these devices. Some commonalities for power considerations for these devices is, first of all MTI devices are powered via 12 volts DC, and typically a power supply is provided as part of that part, whether it's the embedded controller or 620. All power supplies provided for the MTI system should have battery backup that is sufficient for that device, and surge protection. It's utterly important, especially on a control system, that those devices be backed up. The embedded controller should have an independent power source so that it can continue to run even if there's a surge on the MTI data loop or the field devices. The 91620 each one of those should also have their own power supply. And then one device that I didn't mention earlier is the optocoupler, or the 81042, which isolates the data loop, one data loop from another. This can be powered through the data loop itself, or you can provide source power there at the 81042, which allows you to repower the data loop at that point. Grounding is also a very important consideration for these devices. All components of the MTI system function on a floating ground, and that is part of MTI's way of addressing lightning protection. Our approach to lightning protection is through avoidance. We want to isolate the MTI system so that it is in effect invisible to lightning and surges. And one way to accomplish that, or one important factor in that, is the grounding system. Some techniques for ensuring proper grounding is, first of all power supplies should be tied directly to building ground through a building ground bus with the adequate current provided through the wiring of that bus. I have an example there on 0402 of a grounding bar and how to properly connect that. You should, secondly, use fiber optics between buildings, whether that's through your networking or in the case where you might have to run a data loop between buildings, you should do so with an optocoupler so that you isolate those data loops. All cabinets and conduits and faceplates should be properly grounded according to NEC standards. A ground fault creates trouble for any DC system, but especially for an MTI system, it is something that you need to be diligent about eliminating. A ground fault is any wiring that causes the DC side of the MTI system to come in contact with earth ground. This can cause phantom inputs, it can cause surges on the system, it can expose your system unnecessarily to lightning and that sort of thing. So it is always a good practice to eliminate ground faults during the installation and to be diligent to check for them regularly and eliminate them if they were to resurface. Common culprits of ground faults are intercom speaker wires, especially the shield, because oftentimes the shield is not cut back properly on the field side in the staff station, and it ends up touching the conduit or the box and exposes the system to a ground fault. Call-in lines are the same way, and DPS lines. Best practices for avoiding ground faults are, first of all, any unused wiring is best to be cut back and taped off so that it does not have the potential to be exposed to ground. Minimize and isolate splices. If you can avoid a splice either by pulling a cable of the proper length or by shortening the distance, please by all means do so. But if you have to use a splice, be sure to isolate it through insulation, either through a tape or just physically isolated. And then lastly, check your wiring after a lightning strike. A lot of times lightning strikes can damage the wiring systems, and so you want to ensure that the wiring is still good in your system. To find a ground fault, this can take a lot of work to do that, but it is worth it for the longevity of your system. First of all MTI systems come pre-programmed with ground fault indication on the touchscreen devices that are provided. So when you receive indication on the touchscreen of a ground fault alarm, you should take action at that point. That will tell you most of the time the vicinity, the equipment room on which the ground fault is being indicated. Then you can go to the cabinets in that equipment room and look at each one of the 81620s in that cabinet and see if there's one that is indicating a ground fault. There's a red LED next to the network connection on that device, which indicates a ground fault. And then lastly, take a voltmeter and turn it to continuity test and put your black lead of your continuity tester on hard ground, and then put your red lead on each line of the termination board, whether it's your DPS line or your call-in lines or your speaker lines, and test for hard ground through continuity. Once you have continuity, then you can know that that's a ground fault there. One thing that you need to be sure to do is on speaker lines particularly, is remove those speaker lines and test them off of the board so that you don't have those shields tied together there.